Good evening, everyone. Myself Gautam Sharma. I welcome you all on behalf of Sapience Education. So, for more details of our institution, you can visit our website www.sapienceeducation.com. So, today I am going to now discuss about the mainly four topic, uh, that is viscosity, Newton's law, viscosity, Stokes law, terminal velocity, and all. So, one by one step, I will discuss all these things. So, let us understand what is viscosity. See, every fluid has some fluidity. You take water, you take honey. Honey will flow less, but water will flow very high speed. So, what is the difference? Why it is happening? It is happening because it has the viscous property. What is viscous property? Try to understand here viscous property. It is the property of a fluid by virtue of which it opposes the relative opposes the relative motion between its adjacent layer, and it is also known as fluid friction. It is also known as fluid friction. So let us try to understand here from the above this what is happening. So this is the layer of a fluid, right? So see here in above object, if you apply a force, so what will happen? It will try to move ahead, okay? But as soon as the lower layer try to oppose it, so due to the friction force, lower body will also go at some distance. In this way, each and every body layer will try to oppose the motion of above layer. So this property opposes the flow, and the more flow opposes means what? More viscosity is there, means less flow will be there, okay? So for example, in water, if you will take water as well as honey, so honey will flow very less. Why? Because it has a high viscosity. So I hope you have understood now. It is the property of a fluid by virtue of which it opposes the relative motion between its adjacent layer, and this is known as the fluid friction. So I hope you have understood this. Okay. Now let us go for another section. So the what is happening in the internal tangential force which try to return the relative motion retard the relative motion between the layer is called a viscous force. So see what is happening here. Every layer try to oppose the motion. See here, earlier it has velocity what, 10 meter per second. So what happened? Next level step, it has been retarded by next layer, speed become 9 meter per second. Again after that layer it become 8 meter per second. So its velocity is being retarded, okay? And this retardation happens due to viscous force only. This retardation happens due to viscous force only, right? So this is happening due to viscous force. So this force is due to the intermolecular force of attraction between the layer. So basically from where this type of force are coming? So it is coming from intermolecular force of attraction. So you know that liquid has also an intermolecular force of attraction, and due to that interaction, what is happening? There is an there is an opposing force. There is an opposing force. Okay. I hope you have understood this now. Now let us consider now Newton's law of viscosity, which is very important for class 11. What is Newton's law of viscosity? Now it states that viscous force F acting on the between two layers of a liquid flowing in a streamline motion depends upon the following factor. Here what happened? Force is proportional to area. It means that if area of this layer will be more, then what will happen? Force will be very high. Now it is also telling that velocity gradient between layer. So force is directly proportional to the velocity gradient. What is the velocity gradient? Velocity gradient is what? Velocity, change in velocity with respect to change in distance. So it is also very high. Okay. So the force is directly proportional to this. So when we equate all the both equation one as well as equation two, if you will take at a common, so you are getting efficiency, this constant, and this constant is known as coefficient of viscosity. This coefficient is known as coefficient of viscosity, right? So I hope you have understood. Now this is what all about Newton's law of viscosity. So as per Newton's law, if force of layer is more, so it will create a if area is more, force will be more. If velocity gradient is more, so force will be more. So when we combine this both equation 1 and equation 2, so what we will get? You will get force is equal to n, which is known as coefficient of viscosity, into area into dv by dx. So dv by dx is basically known as velocity gradient. Okay, velocity gradient, right? So I hope you have understood now Newton's law of viscosity. And as per Newton's law of viscosity, the force opposing force is directly proportional to the area of the layer, and directly proportional to the velocity gradient. Gradients, if I am talking about velocity gradient, so what do you mean by velocity gradient? So if I am talking about velocity gradient, it means that the change in a velocity with respect to change in a distance, that is distance between this layer, is known as velocity gradient. Okay, the more it will change, so less gradient will be there. More velocity will be there, more velocity gradient will be there. Okay, so this is what all about Newton's law of viscosity. So I hope you have understood now. So this is the force, okay, as viscous force. This is known as viscous force. This type of force is known as, it is also known as viscous force. This is known as viscous force. Okay, now if area of the layer, suppose so many layers are there, one layer, two layer, three layer, four layer, like this. So if one layer, two layer, three layers are there, so if area of the layer is 1 meter square and dv by dx, that is velocity gradient, velocity change in velocity with respect to change in a displacement, is equal to 1, then the force, viscous force, is equal to the coefficient of viscosity. Okay, so the viscous force is equal to viscous force is equal to coefficient of viscosity. Okay, now the coefficient of viscosity of a liquid is defined as the viscous force per unit area. What I am talking about? Per unit area. I am talking about area is in unit, okay, of a contact between the two layers having a unit velocity gradient. So how much velocity gradient should be? It should be unit. Okay, so this is all about coefficient of viscosity. So this is the definition of coefficient of viscosity. If you talk about SI unit, so SI unit is your Newton second meter square. Why? Because if I am talking about coefficient of viscosity, so this will be equal to force into dx by dv. So force is a unit, dx is your meter, velocity is your meter per second. Okay, so wait. Here you have seen that it is your, see here, if I will again go erase. Okay, let us see here, n is equal to f into dx by a into dv. So force has unit Newton, dx has unit meter, divided by area as the unit meter square, dv is your meter per second. Okay, so if I will cut this, so we will get Newton second by meter square. So this is all about SI unit of coefficient of viscosity. Okay, now what is the dependency of the viscosity of the fluid? So you know that fluid has viscosity. Honey has, for example, you are taking honey as well as water, so you can feel that honey has more viscosity. So the temperature, with the increase in the temperature, cohesive force decrease and hence viscosity increase. So you know that layer has that force of attraction, and this is called cohesive force of attraction. Cohesive and adhesive. Try to understand. There are two types of forces are there. One is your cohesive and another is your adhesive. Cohesive means what? Attraction between same particle. And then adhesive means what? Attraction between different particle. So different type of material. So cohesive means what? Same type of material, that is liquid. Same liquid has a force, cohesive force. Okay, so when we increase the temperature, what is happening? Cohesive force is decreasing, and hence viscosity will decrease, because if cohesive force, that is intermolecular force, will be decrease, then what will happen? Viscosity will decrease. Now again, next is your pressure. So with the increase in a pressure, viscosity increase except water. Yeah. If you increase the fluid's pressure, if you increase the fluid pressure, viscosity, viscosity, that is n, will increase, right? So this is the formula. Pressure is directly proportional to the viscosity. Now again I am talking about density. What is density? So on density, with the increase in a density, viscosity increase. So when we increase the density of any fluid, so suppose this is a density. So if you increase the density, so viscosity will increase. For example, you see the honey has more density in comparison to the water. So as we can say that if density is more, so it means that viscosity is more. So can we write here? Can we write here density is directly proportional. Density is your directly proportional to the viscous coefficient. Pressure is directly proportional to the viscous coefficient. Got it? Now the temperature is inversely proportional to the viscosity coefficient. So these are the dependency of the fluid. I hope you have understood now. Okay. Now here I will discuss about Stokes law. Stokes law. What is Stokes law? See here, when a body moves through a fluid, then fluid exerts a viscous force. So let us consider this is a body. This is the body in right side. This is your body. Okay. So when this body is moving downward, so what will happen? And it is moving downward in the fluid. So these are the fluid. So fluid will oppose it. So fluid is oppose it. Okay. Oppose the motion. Okay. So according to Stokes law, if a sphere of a radius r, having a sphere of r, moves with the velocity v through a fluid, then having a viscosity n, then the viscous force opposing the motion of the sphere is given by, so viscous force has been given by 6 into pi into viscous coefficient into r into v. Okay, so these are the given. I hope you have understood now. Again I am telling you, Stokes law actually gives you the phenomena of a ball. So suppose ball or any sphere are moving downward in a sphere, sphere are moving downward, right? Downward. So if a sphere are moving downward with the there is a fluid, and if there is a fluid, so what will happen? So a fluid will oppose the motion of this object. Why? Because it is just moving with the high speed. So whenever any object will move inside the viscous fluid, so what will happen? It will oppose. What will happen? It will oppose, and the force with which it opposes, that force is called, that force has a value F is equal to that force. Sorry, that force is having a value F is equal to 6 into pi into n, 6 times pi into n into r, where r is your radius of the sphere into velocity of the sphere, so with which it is moving downward. Got it? So this is called the Stokes law. So with the help of Stokes law, we can find out the viscous force of any sphere. So okay, got it? So see here, in this ball, so how many types of force is acting in this ball? How many types of force are acting? So in this ball, see here, one is gravitational force, upward force is your drag force, that is viscous force. Okay, so I hope you have understood this Stokes law, right? Now the one very important phenomena is called terminal velocity. So what is terminal velocity? Actually, what happens here? See here, when an object is moving down, what will happen? When an object will move down, so what will happen? Its acceleration increase. Its velocity increases. Okay. So as its velocity increases due to which acceleration? Either gravitational acceleration or any other types of acceleration. Basically, we will talk about gravitational acceleration only. So when an object is moving down, so what is happening here? Gravitational acceleration. Due to gravitational acceleration, its velocity is increasing. Okay. But what is happening when this object is moving in a fluid, like it may be air or it may be water, honey, milk, anything. So what is happening here actually? So the fluid is opposing, and that fluid is opposing is known as drag force. So force due to gravity is acting downward, but as soon as it is moving in a fluid, so drag force will be applied by the fluid. Okay, and due to this, its acceleration in spite of being acceleration at g is equal to 9.8 meter per second square, what will happen? A time will reach where its velocity will become constant. Okay, so that constant velocity is known as terminal velocity. So let us try to read here definition. As the body falls through a medium, its viscosity goes on increasing, and therefore opposing viscous force goes on increasing. Okay, see here, opposing viscous force. See here, as you can see that formula V. So viscous force is directly proportional to velocity. So what will happen? As soon as ball's velocity will increase, so what will happen? Viscous force will also increase. See here, if velocity is increasing, viscous force will increasing. Now tell me, so what will happen here? What will happen in terminal voltage case? What will happen? Try to understand what will happen. Here, force due to gravity is acting downward, and drag force or viscous force is acting upward. So viscous force is increasing. Why? Because due to acceleration due to gravity, what is happening? Velocity is increasing. But one time a time will come where viscous velocity will stop increasing. Okay, that is acceleration will become zero, or net force will be zero. Why? Because net force due to viscosity as well as force due to gravity, both will become equal. Okay, so at the stage reaches where F V plus F D, that is equal to W, in this stage no net force is acting. Okay, no net force is acting, and they will move with a constant velocity, and which is known as terminal velocity. Okay, now if you talk about terminal velocity here, so in terminal velocity it is the high in terminal velocity, let's just see here. In terminal, it is the highest speed through which the body falls through the fluid. In fluid, maximum velocity which it will attain is known as terminal velocity. So terminal velocity Vt is equal to 2 by 9 into a square. What do you mean by a square? A is the radius of a sphere. So if radius is moving, see here a sphere is moving, so it has radius a, so you use here a, or you can also use r square, so no issue at all. And there is a sigma minus rho. Sigma is the density of a sphere, and rho is the density of the fluid. So see, it has a sigma is the density of the object, and rho is the density of the fluid in which it is moving. and n is the coefficient of viscosity. So by using this relation you will get one of the important relation, and this is the terminal velocity relation. So if you want to find terminal velocity, use this equation, right, use this equation. Okay, so I hope you have understood now. So this is all about terminal velocity. So whatever topic I have told, I have already told that we all have discussed all the topic. And if you want more and more videos, please comment on the given description section, as well as you can also subscribe, because I will come forward for more and more chapter. Okay, thank you everyone.